So what I'd like to do now is introduce our first speaker, who is also a friend, and for many years he's spoken at other Praxis events. He is the Richard and Rhoda Goldman Distinguished Professor of Cognitive Sciences and Linguistics at UC Berkeley, where he has taught since 1972, before some of you were born. Previously, he taught at Harvard and the University of Michigan. His research covers many areas of conceptual analysis within cognitive linguistics, including the nature of human conceptual systems, especially metaphor systems, and the neural foundations of conceptual systems in language. George is the author of many books, including the New York Times bestseller, Don't Think of an Elephant, which is here tonight, completely 2/3 of it revised. It's really a new book that should have probably had a different name, but anyway, it is a new book, Don't Think of an Elephant, and it's here. Metaphors We Live By, Moral Politics, How Liberals and Conservatives Think, and the Political Mind, and there's another one out there, The Thinking Points, which is great, very practical book. So he holds degrees from MIT in mathematics and English literature and a PhD in linguistics. He's America's leading expert on the framing of political ideas and is one of the world's best-known cognitive scientists. Please welcome our friend, George Lakoff.
Thank you, Georgia, and sort of amazing that you can put these conferences together, isn't it? Just incredible. I want to start with a couple of basic facts about brains. In particular, first, a thought is 98% unconscious. You mostly don't know what you're thinking most of the time. Decisions are made unconsciously, usually about half a second before you know that you've made them, but sometimes as much as 7 seconds before you know that you've made them. Just to give you a feel for that. And the next thing that's remarkable is that when you have a very deep understanding of who you are as a person, as a moral being, and so on, you might have different moral systems than other people, like conservatives and progressives have quite different ways of understanding who they are and what the world is like. And that has a consequence, which is you can only understand what your brain allows you to. That facts that come in that do not fit what's in your brain will largely be either ignored, ridiculed, or just dismissed. And that's a very good reason why it is the case that although many conservatives, or most conservatives, like the science of fracking, they don't like the science of global warming, because it doesn't fit the idea of free markets and of the idea of personal, not social responsibility. That is part of who they are. They believe that government should leave them alone, that you should get rid of it, drown it in the bathtub, etc., because it tells people what to do and doesn't give them personal liberty. And if your brain is like that, there's some things you're not going to get simply because people tell you the facts. That is hard to swallow sometimes, but that is one of the reasons why this keeps happening. Now, there's another application of this that's very important that doesn't just apply to conservatives and progressives, but applies to climate scientists. I was at a conference on the environment some years back in 2005. And a distinguished climate scientist gave a great talk and was asked afterwards, was Hurricane Katrina caused by global warming? And he said, oh no, we can't say that any particular hurricane was caused by global warming. Absolutely not. We can't say anything like that. That was the wrong answer. And there's a reason for it. every language in the world has in its grammar a way to express direct causation. Direct causation is, I pick this up and take a drink. You know, something happens right here now. But the environment works by systemic causation. And no language in the world has in its grammar a way to express systemic causation. What's systemic causation? In the environment, it works like this. You have network causes. So, for example, it snows a lot in Washington, D.C., more than you ever saw before. The conservative senators say, hey, there's no global warming, look at all this snow. Now, you know perfectly well that if the Pacific Ocean is warming up, you're going to get more energy in the molecules. It's going to go up into the air, lots more energy. They're going to blow north over the pole and come down with huge amounts more moisture in snow in Washington, D.C. That is a network of causes, systemic causation. Now, you have other cases. There's feedback loops. So, for example, as you all know, I'm sure, the ice cap, the Arctic ice cap, reflects light and heat, okay? As the air gets hotter, it melts. The more it melts, the less it can reflect, the more light and heat get absorbed, and the hotter the atmosphere gets, and so on, and that is a feedback loop. That's part of systemic causation. We know, for example, in Hurricane Sandy, there were interacting causes, systemic causes. So you got, systemic causes coming from over hurricane forming off the coast of Africa, moving toward the east coast. You had the same thing happening with the winds blowing from the Pacific. They intersected with the polar vortex. What happened was the vortex pulled it in, and you get Hurricane Sandy off New York, probabilistically, which is the fourth part. So you have chains of causes, you have feedback, you have intersecting causes, and probability, and any combination of those. That's what systemic causation is. And that can be taught. You can draw pictures of it. It could be shown on every weather report. It could be shown all over the place. It is teachable, but it doesn't arise naturally because children don't experience that. So it's not going to arise naturally in languages of the world. So that's a very important thing to understand. There's something that has to be actually taught as opposed to just people just getting it. Now, even the most simplistic model of global warming requires systemic causation. For example, what's the most simplistic way to think about it? You have energy from the sun coming in the form of light, which creates electromagnetic radiation, hits the earth is cooler. What happens is it gets turned into infrared energy, projects up. The infrared energy is absorbed by greenhouse gases. It doesn't just project out into space immediately. Some of it does slowly. And the result is you get heat accumulating, and it's trapped up there. That's the basic mechanism. Very simple. Takes 4 steps. It's systemic causation. And it's not something that people just get and just intuit. It takes an understanding first of systemic causation and then of the pieces that fit in it. And it's not that hard. It's not a huge system, but it takes understanding that much. Now, when we think about sustainability in a conference, I'm a little worried. And the reason I'm worried is we've hit 401 parts per million. And in 35 years, we got to get down to 350. Mere sustainability won't get us there. We have to do better than sustainability. And that's difficult, especially given countries like China, India, Brazil, Russia, where the idea isn't even there yet. So this is a very important thing. I'm worried about mere sustainability. And what happens is, because already global warming is here. There are no more snows of Kilimanjaro, right? Gone. And that's scary. what has to happen in these 35 years is we have to give back to the earth more than we take, not just sustain. Not clear how to do that, but that is an idea that we have to have. And by the way, it's very important to have the ideas you need. The reason I'm going through this is the following. There's a phenomenon in cognitive science called hypocognition, the lack of ideas you need. And there's a lot of ideas that we need and don't yet have. And I want to go through some of them. For example, if you ask if you think about all the components of global warming, you have CO2, you have, you'll hear about black particles from Mark, you have methane, you have all sorts of other components of global warming. Is there a general principle governing how they all got there? The answer is yes, and it's not something you would ordinarily think about. It goes like this, right? We have energy coming in from the sun. That's our major source of energy, but energy can be transformed into all sorts of other things. And one of the things that happens is photosynthesis and other forms in which energy is stored in a structured way. In plants, in animals, in organisms, what life does is store energy in a structured way. Now, then there's the laws of thermodynamics, right? Basic idea. You have a glass of hot water. You put it in a cold air-conditioned room, leave it there for a while. The water cools off, and the room gets a tiny, tiny bit hotter. Energy is preserved, but the heat's gone out of the glass. The second law of thermodynamics says it's entropy, you can't get it back. It's not going to come just back into the glass. Let me give you another example. My wife Kathleen and I were buying some chocolate for a friend, and it happened to be in a store where it was stored in the sunshine, and the chocolate had melted. And you could no longer see the form it was in. We opened up this package and it was all melted. And we knew that if we put it in the refrigerator that way, it wouldn't get back into the original form. Now you could add energy to it, you could melt it down, you could put it in a mold, etc., but you'd have to add energy to it. It doesn't just get back. The same thing happens with coal or oil. They store energy in that form, in the organisms that made the coal and the oil. That stores. You burn the coal and the oil, goes off into carbon dioxide and lots of other greenhouse gases and into black particles and so on. It doesn't come back just like that. Second law of thermodynamics says it's dispersed. Well, lots of things disperse things. You cut down trees and you do something on the ground. You're dispersing that stored energy. And you're doing it in lots and lots of cases. You have, for example, we have a natural filtration system in the ground called gravel, right? You take the gravel out and you put it in your driveway. Dispersal. It's not going back in the ground and filtering the water. And so on. A lot of things that are called development create entropy environmentally. And the question is, what are we going to do if this has been happening, and lots of other countries are doing it? What happens as we have a drought now, as the Sierra snows melt, as the snows in Tibet melt? You know, what's going to sustain rivers? There's an interesting suggestion for this, which is you need negative entropy. Neg entropy, that is, you need to be able to form other organisms and have them spread that will, again, store energy. There's a name for this. It happens. It's a phenomenon called ecological succession. Now, there are a couple of ecological artists, Helena Newton Harrison and Santa Cruz, who have said, hey, you know, we're worried about India. We're worried about California. When the snows all melt, where the river's going to go? You're going to have, you know, water stored somehow. It'll still rain, but all the rain will just flow out. How are you going to store it? And they said, look, there are certain kinds of plants that not only store water, but that spread, and spread and spread and spread, like ground covers. And the question is, what kinds of plants will best do that? They're running an experiment at Sage Hen up in the Sierras right now on kinds of plants that will store water. That is assuming that we're not going to get back to 350 degrees in 35 years, and that we had better find ways to store water in plants and other kinds of negentropy. We're not thinking in terms of negentropy, but we have to start thinking in terms of it. It's hypocognition. It's an idea we need. It covers all the cases. And what is called development is often entropy creating and the opposite of what is needed in the environment. That's something you know in lots and lots of cases. But these are important ideas. Now, there are a lot of people working on environmental economics as a part of sustainability. And I've looked at that a lot. A lot of those folks are friends, long-term friends. And there are very interesting, obvious principles. And by the way, all of this work is good. It's good work. They say, okay, look, conservation is crucial, and erg saved is an erg that you don't need. You use less energy. Great. Conservation, terrific. Very important thing. It's not fully understood. It's not fully understood. It's like, Ben Franklin said, a penny saved is a penny earned. It's the same way with energy. Now, you also have other ideas when you try to use ideas in the market for environmental economics. And this is not obvious. Take the notion of environmental services. They're services for people, not necessarily for animals, plants, and other things. They're services for us, but what is the word services from? Services are things that companies do for people, and they sell them. So the question is, if there are what are an example of environmental services? You have a watershed of some sort, and what it'll do, among other things, is filter water. Okay, you have a small one, and somebody says, hey, I think on this stream, I really want to build a large hotel. They said, no, this is going to be bad for the environment, the water won't be filtered here, blah, blah, blah. He said, well, look, I'll build a filtration plant, and I'll make the hotel big enough that even with the filtration plant in there, I'll still make a big profit. And then the issue comes up in the marketplace is which does the environmental service better? How would you tell? Cost-benefit analysis. What does cost-benefit analysis look like mathematically? There's an equation. The equation is an integral, a sum. It's the sum of a particular thing. It has to be some very particular measurable thing, like the hotel versus, the watershed. Some particular thing and the amount of filtration you would have. And then you ask, and what is cost? Cost is, among other things in economics, the lack of profit. That is, it's a cost to not build the hotel because the profit could be made. So the lack of the profit turns out to be a cost as opposed to a benefit. Okay? Now, in order to measure cost and benefit, you need a starting point and an ending point. And that must be measurable. Nature doesn't end, we hope. In order to do that measurement and that calculation, what will happen is nature will always lose. As soon as you start doing it, it turns out that the benefit is going to be greater from building the hotel because its cost is not building it. As long as you're using cost-benefit analysis and the traditional way of thinking in terms of markets. So when you're thinking in terms of things like ecological services, you better be very, very careful about things like that. It's an idea that is very tricky, and you can't just do it and use it and say, oh, there are a lot of good ecological services out there, because that's going to be understood in terms of markets and traditional markets. Now, this raises a very important thing. It says, what kinds of ideas are there, and how do we act? We act on our ideas. We act on what we understand. What does language have to do with that? Everything. Because words mean things. Words are characterized in terms of structures called frames. They're neural circuitry in the brain. They're frames. Now, every word in the world is defined relative to some frame or other, and frames generalize over whole collections of words. So you have a frame for a week in which you have Monday, Tuesday, Wednesday, Thursday, Friday, and a weekend, and so on. That's one kind of frame. You have frames for utensils, knife, fork, spoon, and how you use them. You have frames for commercial events, buying, selling, goods, price, cost, etc. All those words, and each frame, or a restaurant, you have waiters, chefs, dishes, menus, and so on. Each of those things is called a semantic role, like, a waiter, a customer, etc. A meal, the check. That's a semantic role. And there are relations between those and things that happen in a restaurant and things that don't happen in a restaurant. Hopefully, herds of elephant don't come through the restaurant. Hopefully, nobody's going to come to your table wheeling a patient that's about to be operated on, and they give you a scalpel. That's not supposed to happen in the restaurant. That's called breaking the frame. So it turns out you can't think or use any language at all without having frames. You do it all the time, and the neural circuits that are there, they're everywhere. And the question is, what words have what frames? So if you hear a word like price, you're thinking in terms of some commercial event, right? And if you're not selling something, you're a customer. The price is something you pay. So when you put a price on carbon, people think, oh, what am I going to have to pay? When that's not the intention economically, but that's what people will understand. And it's not just your intention. When you start using words from economics, you've got to worry about what people will understand. You talk about a carbon tax. Now, this happened in Australia recently. They had a carbon tax. And they had a carbon tax that was working for a while. It was a tax on electricity companies. And the electricity companies complained that they just had to pass it on to everybody else, and everybody else felt that they were being taxed. The conservatives made it a major issue that this carbon tax, and who the hell knew what carbon was anyway, because carbon is not a normal thing you get in everyday life. This tax was being put on people, and they ran on it, and they won. And the Australian Senate got rid of the carbon tax, right? Disastrous ecologically. And then the people who put on the carbon tax said, we shouldn't have used the word tax. We should have called it putting a price on carbon. It's as bad as tax. They're not thinking about how thinking works. And there's a reason for this that's really deep. The reason is that when they went to college, they didn't study cognitive science or cognitive linguistics or any of those things that tell you how people think, really. They studied political science, law, economics, public policy, which doesn't teach any of those things. What it does teach, and each of those fields teach, is a false theory and an irrational theory of rationality. And I mean that very seriously. It's a theory of reason that comes from 1650, Descartes. Here's how it goes. You may have heard this theory of reason. The theory of reason, and by the way, when I went to school at MIT, I was taught the same thing. The theory of reason goes like this. All thought is conscious. We know it's 98% unconscious, but it says all thought is conscious. Not only that, it's disembodied. It's not there used by your body in any way. Why? Descartes reasoned it had to be disembodied because if it were physical, it had to be not physical. If it were physical, it would be subject to laws of nature in physics and other kinds of laws of nature. And that would mean you would not have absolute free will. Well, thought is physical. It is subject to laws of nature, and we do not have absolute free will. We can only understand what our brains allow us to understand. It's not something people want to hear, but that's the truth, guys. Now, if you believe in science, you've got to believe that too. That's part of science. It's cognitive science. It's neuroscience. Now, then you have another part. It says thought is logic, because Descartes was a mathematician. He's the guy who figured out, the Cartesian plane is after Descartes, right? And he believed that thought was like deduction in geometry, that it was logic. And that's what he wrote, right? Turns out it isn't. It uses frames, it uses metaphors, it uses narratives, it uses all sorts of other structures that are not in logic and go way beyond logic. Okay? Now, he also said, Descartes said, we are rational animals. It's reason that makes us who we are, that makes us more than mere animals who don't have reason and don't think, presumably, more than mere animals that he saw as being like machines. We have the ability to reason. Now, this was really important in 1650. Why? Because what it said was, we don't have to ask other people to reason for us. We don't have to ask nobles or the church or the Pope to reason for us. We can reason for ourselves. And that was a very big deal in 1650. That was what the Enlightenment was about. But in 2014, it's a problem, because that theory of reason doesn't work. And then there's another part of this. There are two more very important parts of this idea. Why is it that we have reason? Well, in order to satisfy our desires. Turns out we have reason for other reasons. We're human beings. We have to function in the world. That is what allows us, and we have evolved to be able to have a big enough brain, structured in the right way, connected to our bodies in the right way, to allow us to think in terms of frames, metaphors, and all these other things. They're not irrational. They're part of normal rationality. Now, there's another part of this. Descartes assumed that this notion of reason could fit the world directly as it is. And then the question arose, how does it do that? Here you have this thing that's not physical, it's abstract. How could it fit the world? And Descartes had an answer. God wouldn't lie to us. Not a great answer. Now, but that's what he said. And people assume that this abstract reason can just fit the world as it is when reason goes through our bodies. We can only understand what our bodies and our brains allow us to understand. It is not just fitting the world as it is. And then there's a last part. What about language? Well, the assumption is that words just name things in the world. So if reason can fit the world, that's where our concepts come from. It should be that language is neutral. Language is never neutral. Language is defined relative to frames, and people have different ones. Now, what that does is say that something very important. We have what are called contested concepts. There are ideas that use the same words, but mean different things to different people, radically different things. And if you want to read about it, I have a book, not out there right now, but it's called Whose Freedom? And what it does is go through the conservative and progressive views of freedom. It is actually dedicated to George W. Bush, who in his second inaugural address used the words freedom, free, and liberty 49 times in 20 minutes. And part of the time, he used it in a way that we all understand, but most of it was conservative uses that made no sense to any progressive. And what I've done is I've gone through each one of them in each case and shown exactly what it means, why a conservative would understand it, why a progressive would understand this opposite notion with the same word. Okay? These are basic things about thought and language and about communication that most people don't know. It's a case of hypocognition, especially in the Democratic Party these days, I'm sad to say, but it's out there. And Republican strategists do a little bit better at it. Because when they go to college, if they take business courses, they take a course in their curriculum called marketing. And people who study marketing study cognitive science and how people really think. So some of the people who do their strategizing know a little bit better. But this is a very serious issue. If all you have is enlightenment reason and the rational actor model, which the rational actor model is a metaphorical thing. I'll just finish with this. The rational actor model gives you a decision tree, and it says, you're moving along this decision tree, and you always want to get to, the optimal, good thing for you at the end. I went to courses about 20 years ago in international relations, taught by one of the mathematicians in the political science department who teaches this, Bob Powell, who's turned out I got to know him very well, he's a good friend. And at one point I said, what is the actual mathematics behind this? You prove theorems, what are your axioms? He said, gee, I never thought about that. So we went to the books and they weren't in any of the books. So we said, okay, we're both studied math, let us figure out the axiomatization needed to get the rational actor model, which we did. There's an essay on this in chapter 21 of a book I wrote called Philosophy in the Flesh. But anyway, we worked it out in great detail, and it turns out that there's a set of axioms, you look at them, they're just axioms. They're things written out in logic. Say, okay, what does this have to do with rationality or action, or rational action? In themselves, nothing. But those axioms define trees. Okay? Some of the axioms are from what's called formal language theory, that defines trees. Some from probability theory, that tells you what's going on at the bottom of these trees that you're trying to get to. And then you have another metaphor that tells you these little tree structures are understood in terms of paths of motion, where there's an actor that's in it, and each node in the tree is a state that he's in, a location he's in. You move from place to place in this tree. And when you try to get to the bottom where you have the highest probability of getting what you want. Okay? And there are all sorts of math about that. Fine. But why is that rational action? Well, there's a universal set of metaphors that states are locations, purposes are destinations you're trying to reach, and action is motion. That means you have this actor in a given state trying to make a choice of what path to take going toward this optimal state at the bottom. Fine, that's rational action, but who is this actor? Well, you need another metaphor for that. The actor could be a firm, it could be a nation, it could be a consumer, it could be all sorts of things. Okay, because it's just mathematics, you can apply it. So here you have 5 levels of metaphor so far, but you need a 6th. Because in order to apply it to a situation, you need to metaphorically understand the mathematics of the situation. You need a mathematics to characterize the situation, and you need a metaphor to say what that is so that all these other metaphors will fit it. That's called the rational actor model. 6 levels of metaphor in the rational actor model, and to evaluate it, you have to start at a time and end at a time. Now, in international relations, this is a little tricky, because when you start at a time, it says, no time before the starting time matters. The past doesn't count. And after the time you evaluated, the future doesn't count. Now, in the Middle East, the past kind of counts. Boy, does it count. And in environmentalism, boy, does the future count. This is a form of mathematics that should not be used in either of those cases. But people use it assuming that math is just out there in the world, it just exists in the world by itself. It doesn't. It has to be understood conceptually. It means something. And that's what I'm trying to say about all of this stuff. We have a dearth of ideas that we need, of major forms of hypocognition. And we have 35 years, and we better get it straight. Thank you.